Look, I got the good cat content because that's what you come to these videos for. Last week, we looked at a while loop, which was a loop that we used to essentially iterate, loop over and over and over again, repeat instructions, until a given condition was no longer true. Today, we're going to look at a different kind of loop, the for loop, which allows us to repeat instructions over and over and over again until we actually use up a countable resource. Here's an interesting problem. I want to know how complex the names I call my cat are. Now, the way I'm going to measure complexity here is I'm going to look at each name, look at its length, how many letters are in it, and then find the average length of a cat name that I call my cat. We're going to detour into a couple of concepts first, however, to look at for loops, because that's the ideal construct for us to use to look at this data structure. So while loops iterated by using conditions. They looped over and over until some condition wasn't true, some value had changed, or some condition was no longer applicable. For loops are experts at counting stuff. Now we know that lists have a finite length, and in this case, 5 items. So we know that if we are going to loop over something using a for loop and for loops count, then we should expect that the for loop should loop 5 times. But let's imagine that, and in most cases we won't know that there's only 5 items in our list. How do we handle that, or how do we use for loops to just count something of an unknown size? But that definitely has a size. Again, lists always have a size. They never don't have a size. So how do we know how to use for loops in order to count those? Well, first we're going to start our syntax off a little bit differently with just a different syntax word, for. It highlights green, knows that we're on the right path. Here, we're going to also depart a bit by not using a condition and not putting in something that is a definite count. We're actually going to create a temporary variable called name to represent each item in the list. So we're going to say for name in cat names. And this line essentially says for every item name in data structure, the list, cat names, do the following thing. So the colon tells us that when we hit enter, we're going to get an indent there. So we are indicating membership. But I'm just going to print each name in order to demonstrate that my loop is only going to go through this 5 times. It's going to go item to item in the list. And as I print all of my names, I see that, again, it matches the order in my list, and it does it one at a time. So the syntax here is that we're looking for every item, and the item is called some variable in some data structure. Do something. Now, one thing that's interesting about for loops is the minute that the for loop is done, even though we snapped name into being only kind of temporarily, it actually still exists, but it holds the last value that we've seen. So name is now the last value. So after it iterates through every single item in the list, it's going to hold the value of the last one. But it goes through in turn, again, item by item, looking at it and storing it in name until it gets to that last one, and the last one is just what's sort of left around. Now, I know you came for the main event. You came to see how complex my cat names really are. There's one thing I'm going to address, though, before we get there, and that's something we're actually going to see more of next week, but it's something we've already seen this week but applies to strings. We can actually also ask questions of strings that are similar to lists, and we'll see the reason for that next week. However, if I were to use the len function on name, I get the fact that there are 12 characters here. This includes spaces. So there are 12 characters in this string. So that gives me an idea. I can use the len function to get the value, at least the length value, of each name. And if I take my average, which again, the average is just a total of all the letters over the number of items in the list, and we know how to do kind of both of those things. If I use this toward that end, I should be able to use a for loop to go item by item, counting sort of all my items for me, keeping track of where it is, and do the thing that allows me to average all of my cat name lengths. So we're going to use a for loop in that way to solve this particular problem. I'm going to scroll down just a little bit to put the code up at the top of the screen. So I'm going to reproduce the for loop that I created earlier on in this exercise today. I'm going to say for name in cat names. And again, this is going to go each item one by one through my list in order, storing it temporarily as name until it gets to the end. And then once it's hit the end of the data structure, it has exhausted the count. It's gone through all 5. it will finish. So I'm going to create 4 name and cat names, and I'm actually just going to print len name, because if I can do this, if I can print the length of every single name, then I know that I'm well on my way to figuring out how I might do my average. So I'm going to shift enter, and I see that I have a bunch of different lengths. And if I correspond that with my list, I see boss is 4, snooze bagoo seems to be 12, bugman is 11. So it looks like I'm able to use this toward that purpose. I'm actually going to create another variable just to track the sum of all of these things. So I'm looking at each one individually. I need to store those numbers, and I need to increment if I'm going to do my average. I need to increment some value by the total number of letters I've seen. I'm just going to call this letters. So I'm going to assign it as 0. And substitute in here, instead of a print, I'm going to say letters should plus gets the value of len name. So for each length, it's going to add itself to letters. So I'm going to look at letters at the end here and see how this is doing for me. And of course, I need to spell my variable names correctly. If you hit a name error, that means either something is not declared or you have misspelled something, and I have misspelled something here. So if I print letters, I see that I have 44 total letters. So if I were to add up all of the letters in all of these particular names that I call my cat, I would get 44. And that's interesting enough, because now that I've done that, I can actually use this toward my final goal. Again, lists have a finite length, so I've been using the property of strings that they also have a len value. I also can use my len of my list to do that final average, which is over len of cat names. And I don't even have to know. I can change the amount of cat names that I actually have in my list, and this should still work, again, because the for loop keeps track of how many names there are in the list. And if I use len cat names, however many names there actually are in the list will come back. So I'm able to not really care about specifically tracking the amount of items that are in my list. So I should be able to see now how complex my cat names are and see how good I'm doing with teaching my cat English, which has been a secret goal of mine for several years. So it looks like 8.8. So every name that I call my cat has an average of 8.8 letters, which seems pretty complex. So just another short video that introduces us to the for loop and the ways that we can use it with lists. Again, for loops are things that iterate similar to whiles, but they count. We're going to see more about lists and more about for loops this week during our activities, so I look forward to solving problems with these new strategies with you.